Hi all, today I am going to explain about queue processor in Pega. Queue processor uses Kafka server to queue the items, whereas standard agents uses database tables, PRCs queues to queue the items. It creates an instance in system queue default entry class using queue for processing agent activity method. Queue processor rule contains two parts, queue processor producer and queue processor consumer. Queue processor producer publishes message to the Kafka topic server using queue for processing method in an activity rule or run in background smartshape in flow rule. Queue processor consumer is a real-time data flow that consumes a message from the Kafka topic, and once messages are consumed from the Kafka topic server, it executes the logic mentioned in the activity of the queue processor rule. I'll show you in the diagram how the messages are published, how the messages are consumed. Producer and the consumer. Producer publishes message to the Kafka topic using queue for processing method in an activity rule or run in background smartshape in flow rule. And queue processor consumer is a real-time data flow that consumes a message from the Kafka topic. And once messages are consumed from the Kafka topic, the execution logic mentioned in the activity rule will be processed. The same diagram representation, I'll explain it in the Designer Studio. In the Designer Studio, let's take the flow. In the flow, we are using the background smartshape as a dedicated queue processor. The queue processor used for sending the messages to the Kafka topic server. The background smartshape is being used for sending the messages to the Kafka topic partition server. And also, there will be another method called as queue for processing method. This queue for processing method also can be used for sending the message to the Kafka topic partition server. So, conclusion is there are two ways to send the messages, to produce the messages to the Kafka topic server. One way is using the queue for processing method in an activity rule. Second way is using the run in background smartshape in flow rule. If both ways are used, this will publish the messages into the Kafka topic. I'll show you in the diagram. This contribute to the producer part. This is producer, and what is a consumer? Consumer is a real-time data flow that consumes the messages from the Kafka topic server. Once the messages are available in the Kafka topic and the messages are consumed by the real-time data flow, and once they are consumed, the execution logic mentioned in the queue processor activity will start processing. So I'll show you the real-time data flow. This is a real-time data flow. This will be running. This has processed nearly 17 records. The start time was it was running from June 29. From June 29th, it was running continuously. It was not stopped. When we enable the queue processor, this will be enabled. When you are disabling the queue processor, this will be disabled. This is a backend queue processor data flow which has been created and which has been running, and it will be consuming the messages from the Kafka topic. Once the messages are consumed from the Kafka topic, it gives indication to the system to execute the business logic mentioned in the queue processor rule. What is the business logic mentioned in the queue processor rule? This is a processing activity. The processing activity contains some business logic. The business logic is to send the email to the customers once the case is created. Once the case is created, the email will be sent to the customer. Nothing to worry. I'll provide it explanation with a detailed way in further steps by showing you one real-time example. Just I'm giving you high-level information about what is a producer and what is a consumer. I'm trying to show the pictorial representation of the producer and the consumer. Not only pictorial representation of the producer and consumer, but also I'm showing in the Designer Studio how the producer, what is a producer and what is a consumer. Not only that, coming to the document, I'll show you how the queue processor works. How the queue processor works. What happens is whenever a queue processor rule is created, it will create the queue processor topics, partitions, and real-time data flow. I'll show you how the queue processor, topics, and partitions, how they are created. Queue processor rule is created in the backend automatically. That will happens. The queue processor topics and partitions are created automatically in the backend, and the real-time data flow also will be created in the backend. Just now I shown you one real-time data flow, which will be consuming the messages from the Kafka topic. And once the messages are consumed from the Kafka topic, the business logic will get executed in the activity of the queue processor. This is a business logic to send the email to the customer once the case is created. How the business logic execution will start once the messages are consumed from the Kafka topic. Who will consume the messages from the Kafka topic? Real-time data flow, which is created during the queue processor creation, that will take care of consuming the messages from the Kafka topic. Once the messages are consumed from the Kafka topic, it will indicate the system to execute the business logic mentioned in the activity of the queue processor rule. Just now I shown you the queue processor real-time data flow. Queue processor real-time data flow. This is a queue processor real-time data flow. This contains all the statistics from when it is running, how many records it is being processed, how many times it has run, and all the details, whether it is successful or not. All the information will be provided in this real-time data flow. Here we will not have an option to stop this queue processor real-time data flow. The option to stop the queue processor real-time data flow is you have to go to the queue processor. There will be a button called as enable or disable button. This can help us to stop the queue processor rule. If you stop it, the real-time data flow, which is running in the backend, this will get stopped. Okay. So here the naming, you can observe that whenever a queue processor rule is created, queue processor topics and partitions are created. The queue processor topics and partitions are created with the same naming convention as a queue processor. The naming convention of this, I have created just now one queue processor send email notification to customer. This is the queue processor name with the same naming convention. Queue processor topics and partitions are created. By default, how many partitions will be created is 20 partitions will be created. The number of partitions that will be created by default is 20 partitions. Okay. This is the information. These 2 points will give that information. What another information that another point will give us is I told you already that there will be queue for processing method in an activity rule. Queue for processing method in an activity rule sends the clipboard page, sends the queue for processing method in an activity rule, sends the clipboard page to the queue processor. What queue for processing method will do is it will send the clipboard page to the queue processor rule. Not only queue for processing can do that, even run in background smart shape. This is a run in background smart shape. This is a run in background smart shape. Will also send the clipboard page to the queue processor rule. This also can send the clipboard page, or queue for processing method also can send the clipboard page. Once clipboard page is sent to the queue processor, what happens is at runtime, once queue processor receives the clipboard page, queue processor works together with the stream services. Stream services will help queue processors to map the data to the associated Kafka topic. You might get a question that what is a stream services? Queue processors, if they have to publish the data to the Kafka topic, if they have to publish the Kafka topic, they can't do it alone. They have to take the help of the stream service. Without the help of the stream service, the producers will not publish the data to the Kafka topic. Queue processors and the stream services work together. If the stream service is down, queue processor cannot publish the messages to the Kafka topic. It's like a general example I'll tell you. If there is a mixie will be there, and there will be, you want to grind some of the batters. Without switching on the batter, without electricity, the mixie will not run. Similar way, without stream service. Stream service is an electricity to the queue processor. If the queue processor is just like a physical machine, it's like a machine. It's like a mixie. Without electricity, how the mixer cannot run. Similarly, without stream service, queue processor cannot run. Stream service is down means queue processor cannot publish messages to the Kafka topic. If the stream service is there means queue processor can publish messages to the Kafka topic. If the mixie needs to work means electricity should be there. If the power is not there means mixie will not run. But this is a simple general example we can remember. And next one is queue processor consumer. Once the messages are published into the Kafka topic, queue processor consumer is a real-time data flow that consumes the messages from the Kafka topic. And once the messages are consumed from the Kafka topic, execution logic mentioned in the activity rule will start. The business logic mentioned in the activity rule will start getting processed. Just now I shown that real-time data flow in the backend will be running. It will be reading the message from the Kafka topic. And once the messages are read from the Kafka topic, the execution logic mentioned in the queue processor rule will start. The business logic mentioned in the activity rule will get processed. This is a business logic mentioned in the activity rule. It will get processed. Send email notification to the customer. Send email notification to the customer. It will get processed. And the queue for processing method. And just now I shown you that queue processor consumer is a real-time data flow that consumes the messages from the Kafka topic. And once the messages are consumed from the Kafka topic, it signals, it mentions the system. It asks the system to execute the business logic mentioned in the queue processor activity rule. Here, the real-time data flow is running in the background, and once the messages are available in the Kafka topic, the associated Kafka topic partition, once the messages are being read, it asks the queue processor to execute the business logic mentioned in the activity of the queue processor rule. I already shown you that the business logic is available in this activity. It asks the queue processor to execute the business logic. It asks the queue processor to execute the business logic mentioned in this activity rule. What is the business logic mentioned in this activity rule is, once the case is created, the customer should be notified that the case has been created. So once the case is created, email needs to be sent to the customer. This can be done with the help of simple activity method, send email method. That send simple email activity method, we are passing some parameters and we are trying to send in email. That send email activity business logic is mentioned in the queue processor processing activity. If that needs to be executed, our real-time data flow should be able to consume the messages from the Kafka server. Okay. Here, another one is if the queue processor is configured for immediate processing. This one is if the queue processor is configured for the immediate processing. There will be two kinds of processing will be there, immediate and delayed. I'll explain more detailed in further steps about what is this immediate and what is this delayed queue processing. What happens if it is immediate queue processing is being selected? Currently, I have selected delayed to show you folks with an example for the business use case. But if I select immediate, what will happen is immediately the message will be published into the Kafka topic. Once messages are published into the Kafka topic, the queue processors will be able to consume that messages. The real-time data flow, queue processor consumer real-time data flow will be able to consume the messages immediately. And once the messages are consumed, the business logic mentioned in the activity rule will be starts immediately executing, and the customer will get email immediately. This will happen very fastly. Immediately it will happen. If you select delayed means in a delayed time interval, the message will be sent to the customer once the case is created. Here currently, if I select immediate, even immediate is been selected, the message will not be published into the Kafka topic if the stream service is down. Just now I told you that in a mixie example that if the mixie has to run, the electricity should be there. Similar way, if the queue processor should run, the stream service should be up. Stream service is it will be there in the decisioning services. If the stream service is stopped, if I stop the stream services, the message will not be published into the Kafka topic. The message will be stored into the system message queue processor delayed class. Once the stream service is up, the message will be published into the Kafka server. The message will be published into the Kafka topic. Until then, the message will be available in the system message queue processor delayed class. I'll show you the system message queue processor. This is broken class. This is a delayed class. It will be there. In this class, the system message delayed queue class, the instance will be available. I'll show you once the queue processor is once the stream service is done, how the messages are published into the delayed queue class. Instead of saving the messages into the Kafka topic server, it is not getting stored into the Kafka topic server. I'll show that in next steps. So in another scenario also, the message will be published into the TRC's delayed queue table instead of publishing message into the Kafka topic. Another scenario is if the queue processor is configured with the delayed processing, the message will not be published into the Kafka topic immediately. It will take some time to publish the messages with some delayed time interval. For example, if I give 1 hour, after 1 hour only, the message will get published into the Kafka topic server. Once the messages are published after 1 hour into the Kafka server, the email will be sent to the customer after the case creation. So what happens if I say immediate, email will be sent immediately. What if I say delayed, email will be sent after 1 hour or after 2 hours, after 3 hours. After certain period of time, the mail will not be sent immediately. The mail will be sent after delayed time interval. If you want to send the email to the customer immediately, once the case is being created, we have to select the immediate option. If you want to send the mail to the customer after delayed time interval, after 1 hour, 2 hours, or 3 hours, or 4 hours, we have to choose the option of the delayed. So once you choose the option of the delay time interval, the message will not be published into the Kafka topic immediately. It will take some time. It will store initially in the PRC's delayed queue table. That is, it creates an instance in system message queue processor delayed class. After certain period of time, once the deadline time is reached, that is after 1 hour, then the message will be published into the Kafka topic. Once the message is being published into the Kafka topic, then the mail will be sent to the customer stating that stating that a case has been created. Some kind of message, whatever the message you want to provide in that mail, you can provide it in mail. So this is the system message queue processor delayed item class. And broken items. I want to speak about the broken items. For example, if some of the items are there in the delayed item class, you tried it. I mean, like system has tried 3-4 times. Still, system was not able to process these items. Then system will send that items to the broken class. The instance has been already, a particular instance has been there in the broken class. This instance has been created in the broken class. We can requeue them with the, you can requeue this instance. You have to go to the admin studio and you can have an option called as requeue. When you click on requeue, the instance will get requeued. That can be done with the help of the admin studio. And coming to this parallel processing, I'll explain about, nothing to worry that I hadn't shown how the delayed queue instance will be created in the system message queue processor delayed item class, how the broken item instance will be created in the system message queue processor broken item class. I'll explain it in the further steps. Just I'm trying to explain about theoretical part. Before entering into the practical part, I want to explain the theoretical part so that if we are strong in the basics, it's easy to do the practical part. So coming to the parallel processing, let's talk about the parallel processing. We will take an example of the agents, standard agents. Standard agents will be running on the background processing. Standard agents will be running on the background processing. See, this has been tagged to the background processing. For example, in my personal edition, I have only one node. Standard agents will be running only once at a time. So in the production environment, it might have 3 nodes. The standard agents will be running thrice at a time. This is a maximum parallelism that can be achieved with the help of the standard agents. Maximum 3 times it can run, not more than that. Pega claims that with the help of the queue process, we can increase the performance because we are using the Kafka servers. How the performance can be increased? I'll explain you with an example. See here, I told you that in the backend, when a queue processor rule is created, it will create queue processor topics, partitions, and real-time data flow. This is a queue processor. Send email notification to customer. I have created with the same name. The topics and partitions are being created. With the same naming convention, the topics and partitions are created. So on each partition, there will be one thread will be running to process the data. Like that, by default, when a queue processor is created, 20 partitions in the backend will be created automatically. Not only partitions will be created automatically in the backend, but also what will be created is real-time data flow will also be created. By default, 20 partitions are created. On each and every partition, one thread will be running. Totally 20 threads may run parallelly to process the data in the partition. So 20 threads parallelly running means it increased lot of performance. Multi-threading is possible in the queue processor. Multi-threading is possible in the queue processor. So this is kind of a maximum parallelism that can be achieved is 20. Count is 20 here. We can observe the difference between the standard agents and the queue processor itself. Standard agents can only run thrice at a time. Queue processors can run 20 times on 20 partitions, relatively on 20 partitions, parallelly, creating a thread on each and every partition. So 20 threads will be running on the 20 partitions parallelly. This is the maximum parallelism that can be achieved is 20. The count is 20. Business scenario. So I'll explain it with the business scenario. Currently, up to now, we have seen the practical part of queue processor will uses the Kafka server to queue the items, whereas standard agents uses PRC's queue tables to queue the items. Queue processor publishes the message to the Kafka topic. Queue processor consumer only will take care of receiving the message from the Kafka topic and executes the logic mentioned in the activity of the queue processor rule. How it happens, theoretically, I have explained you. But practically, I'll show you what is this queue processor rule, how it is being created, how it is being created with the use case. What are the configurations we have to use for setting the queue processor rule? Everything I'm going to explain it in next steps. Yeah, let's discuss about the configurations of a queue processor rule. I try to create a new queue processor rule. This queue processor, what it will do is, once a case is created, after a certain period of time, that is after 40 seconds, generally we can take 1 hour, 2 hours, 3 hours, or 4 hours. Now for explanation of the business scenario, after 40 seconds, I will send an email to the customer once the case is created. So I created a queue processor rule. I'll explain the configurations of this queue processor rule. There is a button called as enable or disable button. This enables the queue processors or disables the queue processors. If you disable the queue processor will not run. Even the case is created also, what it will do is the email will not be sent to the customer. The queue processor will not be running. And next one is associated with node type. There will be multiple nodes will be there. Ideally, the queue processor will be tagged to the background processing. And when to process? Already I mentioned that immediate and delayed. Immediate means the message will be published to the Kafka topic immediately. Message will be published to the Kafka topic immediately. Once the case is created, the email will be sent to the customer immediately. Not even it will take 40 seconds. Within 1 second, fraction of seconds, once the case is created, the mail will be sent to the customer. Even instead of 40 seconds, if I take 1 hour, immediately if I mention it, it delayed only for 1 hour is applicable for a delayed only. If I mention immediate means it will immediately send it. If I take it delayed as 1 hour, after 1 hour only the email will be sent to the customer. If I take it delayed as 2 hours, after 2 hours only the mail will be sent to the customer. If I take immediate means within fraction of seconds the mail will be sent to the customer. For example, if I create a case now, if I try to create a case now, immediately I'll show you that case will get created. Now, if I keep the delayed timing, if I keep 3 hours, once a case is created, after 3 hours only you'll be able to see the case. If you are able to see the mail is sent to the customer. If I keep it as 4 hours, after 4 hours only mail will be sent to the customer. So this kind of delayed time interval can be mentioned with the help of the queue processor. Number of threads per node. This is a concept we already discussed. Number of threads per node is whenever a queue processor is created, queue processor topics, partitions, and real-time data flow will be created. And just now I shown you that in the Kafka instance, the queue processor topics and partitions are created with the same naming convention as a queue processor rule. Just send email notification to customer is a queue topic partitions which are created automatically in the backend once a queue processor rule is created. This is a queue processor rule, send email notification to customer with the same naming convention only in the backend. In the Kafka instance, queue processor topics and partitions are created. I have shown you by default 20 partitions are created. On each and every partition, one thread will be running, one thread might run to process the data. The maximum number of threads that can run on 20 partitions will be 20 threads. This is a maximum parallelism that can be achieved. This way in the queue process, we can improve the performance. Already I discussed the same point earlier, some time back. So what is the thread count you can give per node? Maximum number of threads is I can give is 20. I can give even 50 thread count also, or 60 thread count also, 80 thread count also, but it will eat resources. Because the maximum number of partitions are there is 20, that many number of threads only you have to give it. We should not exceed the number of thread count, which will only eat up the resources. We should be very mindful in giving the thread count. If we are giving more threads means more resources will be killed. Unnecessarily, it will create more threads, but it will be of no use. It will not help you to improve your performance. Just how many partitions are there, that many threads only you should give it. Maximum threads only you have to give it. You can give 10 threads, 5 threads also. It will not be any problem. It will not kill the system resources. It will not eat up the system resources. When the system resources will get affected is when you are trying to give more number of threads, then only the system resources will get affected. So for example, if I have one node means the maximum thread count I can give is 20. If I have 2 nodes means the maximum thread count I can give is 10. Because on each and every node, 10 threads can run. So 2 nodes, 20 threads can run. This is the maximum number of parallelism we can achieve. And next one is what happens. Just now I told you also, if we have 2 nodes, then you can give 10. This is a point it is been mentioned. Next, retry attempts. Retry, I would like to explain you with this Designer Studio queue processor rule. 2 seconds here. Retry means the maximum, even even one attempt is made to send an email to the customer that has not happened, then the system waits in system message queue processor delayed attempt class. It will go for the retries. Even multiple retries has happened. Even after multiple retries, still the message is not been processed. Even the email is not been sent to the customer. Then the message will be directly sent to the broken attempt class. Here, the maximum attempts I have mentioned is 3. Maximum attempts mentioned is 3. The initial delay is 1 minute. Initial delay is 1 minute means system needs to wait for the processing to be happened is 1 minute. For the next attempt to be happened, it should wait for 1 minute. After 1 minute only, the first retry needs to happen. For example, I'll explain in the document. For example, queue processor been scheduled to run at 4 p.m. Okay. Initial delay is 1 minute. Initial delay is 1 minute. If you have to go for the first retry attempt, you have to wait for 1 minute for the next processing time to happen. 4 p.m. plus 1 p.m. is equals to 4:1 p.m. Initial delay. We should not, even the delay factor is being mentioned in the queue processor rule. Even the delay factor is being mentioned. In the first retry attempt, we should not use it for the calculation purpose. To find out at what time the next processing will happens. Next first retry attempt will happens. We should not take into the consideration the delay factor. We should only take into the consideration only the scheduled time plus initial delay. Initial delay is the processing time. System should wait for next attempt should happen for the next 1 minute. First retry attempt will be original processor plus initial delay 4:1 p.m. Here delay is equals to 1. Second retry attempt will be next when it comes to the second retry attempt, then the delay factor will be taken into the consideration. So the calculation for this is first retry attempt plus delay into delay factor is equals to 4:3. Now delay is equals to 2. Third retry attempt will be second retry attempt plus you have to increase 1 minute for the delay time, initial delay time into delay factor. 2 into 2, 4. 4:3 plus 3, 4, 4:7. This is a calculation we should use for calculating the attempts, retry attempts. Second retry attempt, third retry attempt, first retry attempt. The processing activity, the name itself indicates that it executes the business logic mentioned in the processing activity. Just now I told you that whenever queue processor consumer consumes a message from the Kafka topic, the execution logic mentioned in the queue processor will begin. I'll show you queue processing activity is being mentioned in the queue processor rule. Execution logic activity is mentioned in the queue processor rule. Once the queue processor what happens is once processing logic he mentioned in this activity he needs to be started means just now I was telling that queue processor consumer will be consuming the message from the Kafka topic. Once the messages are consumed from the Kafka topic, the execution logic mentioned in the queue processor will start processing. I want to show it in the designer studio, so I'm reiterating the same point again and again because it will be easy to memorize and correlate with the points whatever I'm trying to say theoretically with the practical in the designer studio. In the designer studio, I'm showing you, right, the real-time data flow I shown you. Once the real-time data flow, this is the real-time data flow, consumes the messages. It will consumes the message from the Kafka topic. It will go immediately and see in the queue processor rule. It will happens in the backend only. System only will take care of checking the queue processor business activity. This is like a destination activity. Source is the topic partitions. Whatever the messages which are available in the topic partition, this real-time data flow will take that messages and it will check it out which activity which queue processor needs to be executed. So it will see, if we observe here, the name of the queue processor which is appearing here in this real-time data flow is send email notification to the customer. Then real-time data flow will go and search for that queue processor rule. Then it has found out the queue processor rule. Send email notification to the customer. Okay, I got this queue processor rule. I need to search for the queue processing activity, because in the queue processor activity only the business logic is being mentioned. The business logic, what is being shown, what is being mentioned by the business is, you have to send an email to the customer once the case is created, but it is immediate or delayed execution. It is a delayed execution. It should not happen immediately. It should happen delayed. I mean, after certain period of time only the mail should be sent to the customer. So I mentioned it as after certain period of time only the mail should be sent to the customer. So the business logic is just I'm sending an email to the customer, but I had to delay it. How I can delay it? With the help of whom I can delay it? With the help of two methods, I can delay it. With the help of two methods. How the methods, which methods? With the help of two ways. One is run in background smart shape. Here, I'm setting the delayed time interval in the py node property. In py node property, this is one way. Another way is in an activity. In an activity, another activity being used, that is queue for processing method. With the help of the queue for processing method, I'm adding a time, date time, 40 seconds being added. After 40 seconds only, the customer will receive an email. He will not receive an email immediately. Send email will be sent to the customer after 40 seconds of the time only. After delayed time interval only, the mail will be sent to the customer. So this is a one, there are two ways, run in background smart shape. With the help of the run in background smart shape, with the help of the queue for processing method in an activity, the mail will be sent to the customer. It will not happen immediately. It will happen only after delayed time interval. So we had a discussion about theoretically how the email being sent to the customer after delayed time interval. I've explained theoretically complete information. Now let's enter into the practicals. Let's enter into the practicals. This is bit more time-taking video of the theoretical part, because if you learn these basics, it's very easy to implement the practical part. If you see this flow, I have provided two shapes. One is utility shape, another is background shape, background smart shape. In the utility shape, I am trying to send the email to the customer after delayed time interval once a case is created. After a case is created, after 40 seconds, I'm trying to send the email to the customer. Okay, this is one way I'm using it. Another way is I'm using run in background smart shape. I'm trying to delay it. I'm trying to send case after 40 seconds. So this py note, I'm setting this value where? In the py note, I'm setting the value here in the flow action. If you go to this flow action data transform, in the post-processing data transform, you can observe that the property value is being set. Property value will be set. Py node value will be set to 40 seconds will be set. 40 seconds will be added. So 40 seconds being added into the py node. This py node property being used in the run in background smart shape. And in the queue for processing method, I'm directly adding the add to date time property function being used for adding the 40 seconds to the current date time. So once the case is created, after 40 seconds, the mail will be sent to the customer. External mail will be sent to the customer. So you can see that why you might ask that only why can't you use only one run in background smart shape alone for sending the email? Why you're using a utility and you're trying to use a queue for processing method? You can use either of this one, right? To say publish the message to the Kafka server. Why you're using the both of these things? Just for the demo purpose, I'm trying to show both methods, queue for processing method or run in background Smartshape, how the email will be sent to the customer in a delayed time interval. Just to show the both the ways, in run in background Smartshape, I'm setting the property value in the post-processing data transform, and in this one, in utility shape, I'm trying to set the date time, adding the date time with 40 seconds and trying to send the email after a certain period of time. Like this, with the two shapes, I'm trying to do it. Two shapes, I'm trying to do it. So you can find out two emails being sent to the customer. Once a case is created, after 40 seconds of time interval, two mails will be sent to the customer. Okay. So now let's create a case and see how the mails will be sent to the customer. How two mails will be sent to the customer. I'm attaching your document. I'm trying to create a case. Once a case is created, you can see a mail has been sent to the customer email ID. So if you see this is the email ID, Pega Pro CJ videos. We'll wait for a certain period of time. Still, immediately the mail has not been received once the case has been created to the customer. We'll wait for 40 seconds. After 40 seconds, you can see two mails has been sent to the customer. The customer here is Pega Pro CJ videos. Already email has been configured. You might get a doubt that where this email configuration has been done. There is an email, there have been simple call send simple email method has been used here. You can use this method for sending email to the customer. I'm passing all the necessary parameters using this activity. This activity only been called in both the places, in the queue for processing method and run in background Smartshape. In both the places, this activity been called. If you want to see this, if you see this, in run in background Smartshape, there is a queue processor. In the queue processor, the activity which has been called is sending a simple email activity. And in the queue for processing method also, if you go to the queue for processing method activity, queue for processing method activity, there will be another email, the queue processor being called. In the queue processor, they are again sending an email to the customer. So there will be two mails being sent to the customer. Send email to the customer. So this is one example. I would like to explain about how to replace standard, how to replace. This is the screenshots related to this sending the emails using the run in background Smartshape or queue for processing method in an activity rule. Now the question is how to replace the legacy agents with the queue processor rules. Because in further future, they might ask you to replace the standard agents with the queue processor rules. First, you have to find out the queue for processing method. You go to the standard agent activity. You search for the queue for processing, queue for agent method. This is a queue for agent method. You comment this queue for agent method and add comment, or you can delete that particular step itself. You can add the queue for processing method. And in the queue for processing method, queue for processing method, you can mention what kind of processor you want to select, whether it is a standard queue processor or whether it is a dedicated queue processor. If we are selecting the standard queue processor, what will happen is there will be out-of-box PZ standard queue processor, which will publish messages to the Kafka topic. You don't need to create any queue processor rule. As I have created here, you don't need to create any queue processor rule. Here, system only will have their own out-of-box processor, PZ standard queue processor, which takes care of executing the business logic mentioned in the activity. Whatever the business logic, this directly you can mention this activity. The PZ standard queue processor will take care of executing the logic mentioned in the activity. What happens if I mention it as delayed? Just now I shown you that after certain period of time only, the mail will be sent to the customer. The business logic and mentioned in the activity will get executed only after certain period of time. It's not happens immediately. When you take the delayed queue processor and you have to create your own customer queue processor rule. I created this queue processor rule. You will not have Pega OOTB out of box queue processor rule for this. Okay. Once Pega queue processor rule and this when you find out this if get a business requirements clarification that whether you had to delay it or whether you had to send the email to the customer immediately, such kind of business requirement you got it from the customer stating that you had to happen this immediately, whether it is a notification should be received immediately or after delayed time interval, that such kind of requirements you got clarity from the business, you can select which kind of processor you want to use it for the queue for processing method, whether it is a standard queue processor or whether it is a delayed queue processor. Once you got the clarity of which type of queue processor you are going to use it, once you select it, you have to mention the activity name. How you are going to identify what is the activity name? Just go to the activities, agents, standard agents. In the standard agent, go to the agent name. In that agent name, you can find out the activity. Just you go and give the activity which is available in the standard agent in the queue for processing method step. That's it. The standard agents has been replaced. Queue for processing also. Queue for processing delayed queue processor. Delayed means dedicated queue processor. Just you have to mention the dedicated one, and whatever the queue processor you have created, you have to give the name of the queue processor with the delayed time interval. The delayed time interval you have to with the delayed time interval. For that primary using, you have to provide the just now I shown you, right? Queue for processing method helps to publish a message to the Kafka topic is Kafka topic that you have to add some 40 seconds like that. Just I shown you one example. Here I'll show you this example. Queue for processing method. Here add to date. Similarly, I'm adding some time interval to delay it from 40 seconds or 30 seconds or 80 seconds. I'm delaying it. So I'm delaying it. If I show this function add to date time, I'll explain more details about this add to date time function. Hours, minutes, days, hours, minutes, and seconds. Seconds has been added 40 seconds. If I want to add hours, means I will add 1 hour. If I want to add days, this is minutes, 60 minutes. If I want to add hour, 2 hours. If I want to add days, if I can add it, I can delay it. After 1 day, I want to send the message to the customer stating that the case has been created. Once the case has been created, the customer needs to be notified after a very delayed time interval. It might be 30 seconds, it might be 60 seconds, after 1 hour, 2 hours, or 1 day, 2 days, 3 days. Everything you can specify in this add to date time function, and you can mention it in the date time for processing box. And you can lock it using the primary page or key defined on the property. Generally, you'll use the primary page only. And once you select the primary pages, that's it. The replacement of the standard agents to queue processes has been completed. And I'll show you earlier, we were discussing that how to requeue the items which are there in the Broken Studio. Broken items is, we'll go to the admin studio. We'll go to the admin studio and we'll go to the broken part and we'll requeue it. We'll go to the broken part, system, resources, queue process, broken item. We'll see one broken item is there in the queue process. If you go to this particular area, we'll have an option to select this particular checkbox and requeue it. Using this button, you can requeue this item. You can requeue any broken items. Any items which are requeued, it will be broken. You can requeue it. With the help of the admin studio, you can requeue the broken items. So earlier also I was stating about, I'll show once again recap of what is being discussed. And so this complete diagram only will help you to remember how the queue processor works. Queue processor is used to queue the items from the Kafka server. How the queue processor producer publishes message to the Kafka topic. Using queue for processing method are run in background Smartshape in flow rule. Queue processor consumer is a real-time data flow that consumes a message from the Kafka topic. And once the messages are consumed from the Kafka topic, execution logic mentioned in the activity of the queue processor will begin. What the execution logic in the activity rule will do is, it will start sending email notification to the customers once after a certain period of time, once a case is created. Once a case is created. And coming to this, once a case is created, and a few minutes back also I was saying that if I'm selecting the queue processor as a delay time interval, once I select, it'll go to the records sysadmin, I'll go to the queue processor. In the queue processor, I'm selecting the delay time interval. Already told you that if it is immediate means once the case is created, the mail will be sent to the customer immediately. If I select delayed means, what will happen if delayed is mentioned means, system message queue processor is a class where system creates an instance in that particular class. After certain period of time, once the deadline time is reached, the queue items will be processed. And once the deadline time is reached, the queue items will be processed and the mail notification will be sent to the customer. So, what is the main idea behind this is, for example, if a delayed been selected, after 1 hour only the mail notifications will be sent to the customer. Then what the queue for processing method run in background Smartshape will do is, with the help of the stream services is, it will not publish the message to the Kafka topic immediately. It will save the messages into the queue processor. System message queue processor delayed item class instance. After once the deadline time is reached, the system will be processed from this class instance and published into the Kafka topic. So I'll show you how the message will be stored into the, when you're selecting the delayed class, delayed execution. I selected the delayed execution in the queue processor. The instance will be created in the system message queue processor delayed item class. You'll go and create a case. I'm trying to create a case. I'll fastly create a case. Once the case is created, a mail notification needs to be sent to the customer. So it will not happen immediately because I have selected the delayed execution. So after 40 seconds of that time only, the mail will be sent to the customer. So during that time, the instance will be created in the delayed class. Once after 40 seconds, once the deadline time is reached, the message will be published from the Kafka topic, from the delayed item class instances to the Kafka topic server. See, still there are mails have not been sent. Only 2 mails are there. Now if you refresh it, if you keep on refreshing, the message will be published to the Kafka topic. And once the messages are published to the Kafka topic, the real-time data flow will consume the messages and ask the queue processor to execute the business logic mentioned in that activity. Once the real-time data flow find out the queue processor name, it find out the queue processor name and ask the activity ask the system to execute the activity, execute the business logic mentioned in the activity. What is the business logic mentioned in the activity? It's just sending an email to the customer once the case is created. So we will see whether the whether instances has been deleted from the delayed item class instance or not. If the instances are deleted from the delayed item class, the mails will be sent to the customer. Here, another 2 mails will be sent to the customer. Totally 4 mails is being sent to the customer. Yeah, that's all. Thank you. Sorry for reiterating the same points again and again because it will be easy to memorize. That's why I try to reiterate the same points and again. Thank you for watching. Please like, share, and subscribe.